I can't. The only thing I saw was you saying Professor question mark. But you can ask again. I'm happy to answer it if I can see it. Number 1, part 2. This is on E, right? Yes. Note the question asks for f prime of E, so you're supposed to plug in E there. But before plugging in E, it looks like you agree with me exactly. And then when you plug in E, it should simplify quite a bit. Let me know if there's anything else I can help with. Let's see, so when you plug E into this, you should get E times e to the E minus 1 minus e to the E divided by e to the E. So what's E times e to the E minus 1? I don't think so. So I have here, both of these things have a base of E. One of them is e to the first power. One of them is e to the E minus first power. What do I do with the powers? Add, right. So what do you get? Right. So this is e to the e. So what does that then make this whole thing? Yep, which is what? Better known as. Right. That's right. You'll need the product rule on both the first derivative and the second derivative. let's have a look. Minus 1/2. B is... Let's see. I think you're close. I think it's not quite right. Oh, wait, no. Sorry. Let's see, you did this slightly differently. Okay, so 1/2 x plus... yeah, let's look at this. I don't... I think you're very close, but I think it's not quite right. So... let's write out... x is... So that's what I get for my first derivative, writing it out the way that you did. Okay, you agree with all of that? Yeah, so I think this piece, when I looked at it, was the place that you disagreed with. I think when you factored out this 1 over square root of x, I think something went slightly awry with this term. Did you find where something went wrong for you? Yeah, it looks to me like the thing you did was forget that you needed when you were factoring out the 1 over 2 root x, you forgot to factor that out of the second term. So you just copied the second term as it was when you wrote down your b. That is what it looks like happened to me. Yeah, you should definitely use the product rule on this thing that I've written down here. So you have it written as uh, really, you basically have it written like that, in which case I can take the second derivative by using the product rule here and then just using the power rule on this other part. So if you preferred, you could do it that way. But if you do that, then your a will be the natural log of x, your b will be 1 over twice the square root of x, and then you'll get the derivative of this first piece, and then you'll just add to that the derivative of this second piece. From this second one, the way I wrote it? Sure. So if we did it this way, we'd have a is 1 over 2 root x, b is the natural log of x plus 2. So a prime would be minus 1/4 x to the minus 3 halves. B prime would be 1 over x. This part you did exactly right in your version before. Uh-oh. Camera froze again. Let's check. Yes, the camera froze again. One moment. Properties. There we go. Now it should show up. So there's the a prime b prime. This coming from this line here. So then a prime b will be minus 1/4 x to the minus 3 halves times the natural log of x plus 2 plus, and then ab prime will be 1 over 2 root x times 1 over x. And you could try and simplify this, but I would go ahead and plug in whatever you're asked to plug in before simplifying it, just to make life easier. It's e to the 4th is what they asked for. let me know if you have any more questions. Weird. I got that one. After plugging in e to the fourth, I get minus e to the minus sixth. That's what I got. Yeah, I can run through it. So, f double prime of e to the fourth will be minus 1/4 times e to the fourth to the minus 3/2 times the natural log of e to the fourth plus 2 plus 1 over twice the square root of e to the fourth times 1 over e to the fourth. Okay, that's where we are so far, right, Ryan? Okay, so this is minus 1/4. Okay, I multiply these powers, so that is e to the minus sixth times the log of e to the fourth is 4. And then this will be 1 over square root is the 1/2 power, so this is 2e squared times 1 over e to the fourth. Okay, and I'm going to go ahead and note e squared times e to the fourth is e to the sixth. So this is minus 3/2 times e to the minus sixth plus, and this is now 1/2 e to the minus sixth. And so this is minus 3/2 plus 1/2 times e to the minus sixth, which is minus 1 times e to the minus sixth, which is minus e to the minus sixth. That will do it. also got 1, 1. What doesn't make sense with it in the graph? The x and y the x and y are on different scales. So you're right, but you can eyeball that this looks about a quarter as high as the point question mark 4 and about as a quarter as far to the right as 4 question mark. But you're right, certainly 4 is a lot shorter on the x-axis than it is on the y-axis. Sorry, other way around. 4 is a lot shorter on the y-axis than it is on the x-axis. Yeah, no problem. It's not a technicality that we've emphasized a lot, the subtleties of all the different ways you can draw the same graph. So I recommend anytime you come across that, you instantly FOIL it out so that you don't get confused. So if someone gives you something like like that and asks you for the derivative, the first thing I think you should do is write that a is 4x squared minus 28x plus 49, and b, I did not leave myself a good amount of room here, b is 16x squared plus 24x plus 9. And then a prime is 8x minus 28. B prime is 32x plus 24. And I would just not acknowledge, basically, that you could write this without foiling it out, because if you try and do it without foiling it out, you're going to get the derivative wrong unless you're lucky. Yep, so I foiled out both of them here before writing it out. So yeah, this is one instance where if you need to take a derivative, you need to foil out a square if it's in the denominator. Yeah, so if I was then writing this derivative, I would write it like this. So I would write a prime is 8x minus 28 times b, which is 16x squared plus 24 plus 9, minus, sorry, I've written this in the worst possible way, ab, which is 4x squared minus 28x plus 49 times 32x plus 24. We're imagining this all being inside the numerator, but then you're right. I would say, okay, I know b can also be written this way, and I prefer denominators factored, so I would write this as 4x plus 3 to the fourth, because that's 4x plus 3 squared squared. Now, you don't have to do that. If you wanted to write this as this squared, that's fine. It's not going to do anything wrong. But knowing that this factored is that lets me keep the denominator clean. Sure, gents. Number 6. Let's see. Oh, sorry. Like that. And then like that. Okay, so when we go ahead and do this, I think it always makes sense to draw the graph of the derivative below the graph of the original function. And we want to carry down all the points where something weird happens, as well as all the points where the derivative is known to be 0. So for example, this is a critical point. The derivative here is 0, so I'll go ahead and carry that down. Okay, and bubble that in because the derivative there is 0. So I know this point, at least, is going to be on the graph of the derivative. Okay. Now, let's look at this a piece at a time. So this parabola piece here is increasing on the left and decreasing on the right, which means the derivative is going to be positive here and negative here. It's probably going to look something like this. Okay. Remember that the derivative of a parabola is a line, so if you believe this is a parabola, you know this should be a line, but in any event, it should slope downward like this. Okay. And then there's a sudden shift here, where suddenly now the derivative is positive, and my picture makes it look less positive than the actual graph. There's a sharp shift here where now this is positive, but it's actually becoming more and more positive. So it looks something like that. Okay. And because of this jump here, I have to put open circles on the graph of the derivative to indicate, hey, the derivative jumped from very negative to very positive suddenly. Okay. I, in fact, get a vertical asymptote here, like that. Okay. Now, for this last piece of the graph, it's increasing, so it's again positive. It's as steep as possible over here and getting less and less steep, but always still being positive, so it's going to end up looking like that. And so that's approximately what our derivative is going to end up looking like at the end of this. Let me know if you have questions about that or any other questions I can help you with. So the first piece here is linear because this is a parabola, whereas This piece is not a parabola. This piece has a vertical asymptote, which parabolas don't. Uh, Again, this is more clear in the original graph than it is in my rendition of the graph. Uh, but if you look here, this vertical asymptote tells me this thing isn't a parabola, so it has to curve. And really, if I look at this, it's clear the graph here is becoming sort of infinitely steep as it goes up this piece of the curve. Does that make sense? Absolutely. Let me know if you have any more questions I can help with. Let's look at number 5. Okay, I agree with you about the 8. Oh, wait, I actually agree with you 8 and 1/11th. Yep, that's exactly what I got. 8 1/11th. Yeah, this is the same thing as before, where the y scale and the x scale are very different because the y coordinate is 1/11th and it looks huge, and the x coordinate is 8 and it looks tiny. Yeah, as a note, you can always use your favorite graphing utility to pull up your own graph of this thing and look at that kind of thing. So, like, if you go to, like, Desmos is probably the most popular one these days, you can pull up a graph and then check this kind of thing for sanity. But I'm glad you're looking at that. It helps that you're using the graph as sort of a sanity check to make sure that these things are good. But even for the questions where I don't give you a graph, you can pull up a graph just to help make sure that your answers make sense. Sure, gents. Okay, so we want the tangent line to y equals e to the x at x equals 3. Okay. So our point in this case is going to be 3e cubed. And our slope is going to be y prime of 3. Oh, I guess I did actually call it f in the question. Now, the derivative of e to the x is just e to the x. So this slope is in fact e cubed. And so my equation of my tangent line looks like y equals e cubed x plus b. And it passes through the point 3e cubed, which means that I can write e cubed equals 3e cubed plus b. So b is minus 2e cubed. And so my equation should be y equals e cubed x minus 2e cubed. Do you have any questions about that? I went through that kind of quickly, but I'm guessing there was one specific part of this that you were struggling with that I can answer questions about. Oh, 3 on the last test. Oh, test 6. Sorry. That was entirely my fault. For not reading the thing. Okay. Let me pull up a copy of test 6. Then I will be happy to do so. Number 3. Okay, so test 6, number 3. Okay, so here we've got h of x is x squared divided by 3 log x plus 2. And we want to know the min and max of this function on the interval 1 over square root of e to e squared. Okay, so we've got to take the derivative here first. So my h prime of x here is going to work out to be 2x times 3 log x plus 2 minus x squared times 3 over x, all divided by b squared. For the closed interval method, which I should emphasize that this is a closed interval method question, I need to know just the critical numbers inside the interval. So in other words, I want to know when this derivative here is 0. So I can just take the numerator here and set it equal to 0. So the numerator here will work out to be 6x log x plus 4x. Okay. And then this here will be 3x. Okay, so this is 6x log of x plus x equals 0. which then is x times 6 log of x plus 1 equals 0. Which goes ahead and gives us ostensibly two critical numbers, one of them being x equals 0, and one of them being whatever I get when I solve 6 natural log of x plus 1 equals 0. This x equals 0 is actually invalid for two reasons. One, 0 is not in this interval, and two, even if it was, I still couldn't plug 0 into this function, so we're just going to throw that one away for either of those reasons, and we'll solve this. Okay, so that is our critical number. X equals e to the minus 1/6. Okay, so now I have to evaluate our function here at the endpoints and there. Sorry, h is our function's name. I'll do that in a second, but do you have any questions about things so far? Ah, there you go. Are you happy with evaluating it at these points, or do you want me to go over that? Find f prime of 3. Let's see. So I can show you what I did when I did it. So I ended up estimating this point, and I guessed that this point was approximately 3 comma 4 into third. Does that seem reasonable? So here's my line. It came really close to passing through 2, 3. And then I guessed the original point was 3 and 4 plus a third. All right, I'm going to wrap things up here, but good luck on the rest of your finals and safe travels home. Enjoy your Thanksgiving. Have a good break. And I'll see you both around.